I'm Varunakshi Bhojani, RCID 1100, MES, Pillai Institute of Information Technology. I'm going to discuss about Vibhakti Identification System for Sanskrit now. It's part of NLP, that is Natural Language Processing. There are various algorithms which are present in natural language which can be used to identify whether what is the Vibhakti for a given noun of Sanskrit. The contents which are going to be discussed here are introduction, motivation, little bit literature survey, introduction to Subanta, that is the noun forms of Sanskrit, system for Vibhakti identification, approaches for Vibhakti identification, and application for the system. And various algorithms are there in natural language processing, or the algorithms which are used in this Subanta identification, which can be reduced to some classical algorithms like pattern matching algorithm. Introduction for this topic is natural language processing is a subfield of artificial intelligence and linguistics. NLP is focused on developing systems that allow computer to communicate with people using everyday language or natural language. Main challenges in natural language is understanding natural language. We know that computer can understand, or we can communicate with computer by using English language, but there are various natural languages like Indian languages which are not yet used to communicate with computer. Sanskrit is considered as mother of almost all Indian languages or Indo-Aryan languages. It is this language is very rich with literature like poetry and drama. And this material is not accessible to the scientists who do not have enough exposure to Sanskrit language. With the help of natural language processing and Sanskrit grammar, one can develop an appropriate tool for accessing Sanskrit text. This Vibhakti identification is one of the very important or crucial part in identification or in understanding this Sanskrit text. Sanskrit is the most ancient language in the world. It is the source of science including physics, chemistry, mathematics, agriculture, astrology, medicine, and many more. Being a heritage language, there is need to digitize and preserve ancient texts in Sanskrit. So many researchers have developed tools for different languages, for example Latin, Greek, but comparatively that much work is not done for Sanskrit language. The literature survey is done with some papers. The work is basically done in IIT Bombay and Jawahar Nehru University, JNU. Introduction to Subanta. In Sanskrit sentence, all non-verb categories are Subanta padas. Nominal inflection deals with combination of bases with case suffixes. For example, the root word is bal, inflected form is balam. Words are basically of two types, declinable and undeclinable, indeclinable. Nouns are declinable, pronouns, adverb, and verbs are also declinable. There are 21 vibhaktis which are given by Paninian grammar. Singular, plural, and dual. These are three numbers which are given in Sanskrit. Basically, in English language we have two, that is singular and plural we generally use. But in Sanskrit language we have three numbers and total 8 vibhaktis are there. So like Prathama, Dvitiya, Tritiya, and so on. So each one is having each number, each vibhakti is associated with each number and it is having one suffix. Okay, so likewise there are 21 suffixes, like Su is for singular Prathama, Au is for singular dual Prathama, likewise. The system which I am going to discuss here contained this block diagram. The key task in analysis of vibhakti is identifying the correct root word from its inflected form. So the input text is given, some pre-processing is done. If there are some extra characters are there, so these characters will be removed by using this pre-processing system. Then POS tagging is done. POS tagging is part of speech tagging. There are various natural language processing algorithms which are used for POS tagging. For this POS tagging, verb database and aware database is used. Avyay are those words which are not inflected because of any number, because of any vibhakti, because of any tense. So these are there are some avyay which are not inflected because of in any situation. So after POS tagging, Subanta recognizer is used. There are some exceptions which doesn't follow the rules which are given by Panini. So such words are there in one database called as Vibhakti example database. So these words are recognized. Here also one pattern matching algorithm is used because we are matching whatever the content of Vibhakti example database is there. So we'll match with the words which are there in the Subanta recognizer. Then Subanta analyzer will analyze the actual vibhakti of the word which is not recognized in the previous step. So for this step, Subanta rules are applied and noun database is used, and finally the Subanta analysis is given. For example, Krishna Chandra Naam Kashit Asit is one sentence which is given as an input to this system. So what happens exactly here? In step 1, the input is given. In step 2, we are removing punctuations, or this is also called as pre-processing stage. So here, this vertical bar indicate end of sentence. So this end of sentence is removed here. In step 2, recognition of verb. Here for this particular system, we are only using the subantas or nouns. So if verb is there, that will be recognized as verb and that will be tagged. In step 3, recognition of avyay. In this sentence, Kashit and Naam, these two are avyayas. So these two are recognized and tag is given as avyay. In step 4, recognition of Subanta. Now Krishna Chandra Heart is there, so it is recognized as Subanta. Now we have to identify vibhakti of this Krishna Chandra. So in step 5, and that is analysis of Subanta, we'll use, see how this here one important algorithm is used, that is identification of vibhakti. Krishna Chandra is input to this step. So first we'll try to find out what is the suffix used for this. Here the suffix is aha. So what we will do here, aha, from end of this subject, that is from right side of this Subanta, we'll try to find out what is the possible suffix is. So here we can find that aha. Aha is the possible suffix. So that aha will be stored by using one key, that is a 4-digit key is there. First digit indicate that aha is the possible suffix for prathama ekvachan, akaranta pullingi prathama ekvachan. So first digit in this key indicate the ending character of possible subanta. The second digit indicate whether it is masculine or we can say the gender of this particular subanta. The third one indicate the possible the suffix is possibly for which vibhakti. and the last one indicate number. So here for this aha, aha is the possible suffix for akaranta, pullingi, prathama, ekvachan. So this key which stores this suffix is 1 1 1 1. 1 indicate it is a akaranta. Second one indicate pullingi. Third one indicate it is prathama, and last one indicate it is ekvachan. So finally, what we have to do, this key is given. Key is then recognized by using, in the previous slide we have used some Subanta rules. These Subanta rules are there. So this one will be this particular step is going to use some another 3 databases are there. So it will check, it will mapping table is there. So it will check 1 1 1 1 is what is meaning of this 1 1 1 is. So accordingly it will return the meaning. So for this also we are going to use one matching algorithm, string matching algorithm, and it will return the value of this or the meaning of this 1 1 1 1, that is akaranta, pullinga, prathama, ekvachan. And for rest of the words, that is for naam it is avyay, kashit it is avyay, and for asit it is verb. And finally the result is display. So approaches which are used here for vibhakti identification are 2 approaches, rule based and second one is example based. Example based is more accurate if the database is that much powerful, and in case of the rule based we can say that it is more automated. So if we combine both of these approaches we can give the better results. Application for this system are machine translation, spell checker, question answering system, knowledge representation and reasoning. So there are many more applications. So these are the references which I have used. Thank you.